Researchers were astonished to discover unusual and startling phenomena occurring on Neptune, the eighth and most distant planet from the Sun, known as the god of the vast ocean. Neptune lies beyond the inner solar system, marking the boundary of the dark depths of interstellar space. Despite having a diameter 4 times that of Earth and being 45 billion kilometers away, making it appear small, even to powerful telescopes, Neptune wasn't discovered until 1846. Over the past few decades, scientists have observed dramatic changes in Neptune's atmosphere, raising concerns about what might be happening on this distant planet and how it could potentially impact our daily lives. Neptune is not as frequently discussed as other planets. For example, images of Jupiter's clouds and Mars' surface are often showcased by space probes. Mercury often gets blamed for astrological woes, particularly when it goes into retrograde, which is merely an optical illusion. The Cassini spacecraft famously orbited Saturn for 13 years before making a spectacular end to its observational mission. Planetary scientists have suggested that NASA should prioritize sending a probe to Uranus within the next decade. Recently, Neptune briefly captured attention due to a new study focusing on what gives the planet its striking blue hue. Patrick Irwin, the study's lead author and a planetary physicist at Oxford University, noted that his team aimed to explore the atmospheres of both Neptune and Uranus, rather than specifically investigating the mystery behind Neptune's beautiful appearance. Neptune and Uranus are often classified as ice giants because researchers believe these planets formed from icy materials. They are generally similar in size, larger than Earth but smaller than Jupiter and Saturn, and share many other characteristics. Both are planets without solid surfaces, with atmospheres composed mainly of hydrogen, helium, and a small amount of methane. Scientists theorize that under extreme pressure within these planets, carbon atoms may form diamonds. The methane in the atmospheres of Neptune and Uranus absorbs red wavelengths of sunlight and reflects blues and greens, giving them their characteristic hues. Irwin and his colleagues discovered that a specific layer of haze on Uranus is twice as thick as on Neptune. However, if this haze were absent, the atmospheres would appear naturally blue. They actually become paler when haze is present. The researchers speculate that Neptune's more turbulent atmosphere is better suited for generating and dispersing methane particles, contributing to its status as the bluest planet in our solar system, while Uranus exhibits a softer sea blue color, highlighting their differences. While Neptune should theoretically take its rightful place in the cosmic hierarchy as the farthest planet from the Sun, discussions about Pluto's status as a planet persist. When not debating Pluto's classification, astronomers search for Planet 9, a hypothetical planet believed to orbit the Sun beyond Neptune, potentially explaining the peculiar orbits of several distant celestial bodies. Despite being the last planet in the solar system yet to be visited by a dedicated mission, Neptune was located following the discovery of Uranus. In 1846, astronomers deduced that Uranus's orbit was being influenced by the gravity of an unseen celestial body, leading them to Neptune, which was found exactly where predicted. NASA's Voyager 2 spacecraft flew by Neptune in 1989, providing a close-up view of its striking blue globe, moons, and rings. While Neptune does possess rings, they are not as spectacular as Saturn's and are composed of tiny particles of rock and dust. Since then, no spacecraft has landed on Neptune, as Uranus is closer and more accessible for our probes. Recently, planetary scientists have advocated for prioritizing one of the two ice giants for exploration, considering the immense time required for each planet to orbit the Sun, 84 years for Uranus and a staggering 165 years for Neptune. A targeted mission to Uranus in the mid-2030s could significantly enhance our understanding of both ice giants, yet this approach may overlook the unique history and characteristics of Neptune, which also deserve focused attention. Observations from the Hubble Space Telescope have revealed a massive dark storm raging in Neptune's northern hemisphere, which has been moving south before suddenly changing direction and heading back north. This may have led to the formation of a new dark storm in the process. The term ice giant refers to Neptune, which is essentially a vast sphere of hydrogen and helium gas, containing significant amounts of methane, ammonia, and other compounds. Neptune is the largest planet farthest from the Sun, located about 4.5 billion kilometers away, roughly 4 times Earth's diameter. Scientists were amazed by the images returned by Voyager 2 after its flyby of Neptune in 1989, which revealed a gigantic oval dark storm, known as the Great Dark Spot, approximately the size of Earth, located in the planet's southern hemisphere. This storm was notable for having the highest wind speeds ever recorded in the solar system, reaching up to 2,100 kilometers per hour. However, by 1994, Hubble had detected that the Great Dark Spot had vanished. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's storms appear to form and dissipate over shorter timescales. Hubble's observations in 1994 also identified a smaller dark spot in Neptune's southern hemisphere that likely emerged between Voyager's flyby and Hubble's photographs. Since then, Hubble has observed several additional dark spots that form at mid-latitudes in both hemispheres and tend to move towards the equator, yet they eventually fade away. Methane is particularly adept at absorbing infrared light, which contributes to Neptune's somewhat faint appearance in images captured by the James Webb Space Telescope, JWST. This gas effectively absorbs red light, giving the planet a striking blue appearance. However, Neptune does have high-altitude methane ice clouds, which, unlike gaseous methane, are highly reflective, resembling storms seen on Jupiter. These clouds can be observed at various latitudes above the deeper cloud layers. Neptune possesses a ring system similar to the other gas giants, with these rings likely composed of ice particles coated with various debris, giving them a reddish hue. This composition enhances their brightness in infrared frequencies, making them more visible in JWST images. In addition, Neptune is surrounded by a dozen small moons. The largest, Proteus, measures just over 400 kilometers in diameter, while most of the others are smaller and irregularly shaped, measuring under 200 kilometers. Some of these moons, known as shepherd moons, appear superimposed on the rings and are thought to help maintain the structure of the rings by gravitationally influencing nearby particles. The bright blue-green object in the images is Triton, Neptune's largest moon, which has a diameter of 2,700 kilometers. Larger than our moon but smaller than Pluto. The bright lines seen are diffraction spikes caused by light bending around the three supports holding JWST's secondary mirror. Triton appears bright because it is covered in frozen nitrogen, which is highly reflective. While larger moons like Triton are visible, they often appear fainter when viewed in the context of the vastness of space, especially when the light source is small and referred to as a point source by astronomers. Triton is unique in that it orbits Neptune in the opposite direction of the planet's rotation, leading scientists to hypothesize that it may be a captured Kuiper belt object. In close-up images of Neptune, its clouds and rings become more distinct, revealing some of the fainter ring structures. Interestingly, a very thin, faint line encircles the planet near its equator. Neptune's atmospheric circulation moves from the poles toward the equator, where the gases sink and heat up, making its atmosphere quite different from that of Earth. This warmer gas may be responsible for emitting infrared light. The JWST captures wide-angle views of Neptune and Triton, but the background consists of distant galaxies that are millions or even billions of light-years away, highlighting Neptune's status as the last major outpost in our solar system. Future missions aimed at exploring the outer planets are being discussed, with plans for an orbiter to launch in 2033 and arrive at Neptune in 2049. However, sending a probe to Uranus first could delay the Neptune mission by at least a decade, pushing any potential exploration of Neptune into the 2050s. Exploring Neptune presents challenges beyond its great distance from Earth. Its dynamic and complex atmosphere is characterized by extreme winds and unusual storm patterns. These atmospheric systems operate on a scale distinct from those on Earth, complicating predictions and observations. For instance, dark spots in Neptune's atmosphere can appear and disappear within months, challenging our understanding of planetary weather patterns. Moreover, Neptune's internal structure remains largely unknown. The planet is believed to have a core made of rock and ice surrounded by a thick mantle of water, ammonia, and methane ices. Researchers are still investigating the exact composition and behavior of these materials under the extreme pressures and temperatures found within Neptune. This uncertainty extends to Neptune's magnetic field, which is misaligned with its rotation axis, indicating a complex internal dynamo mechanism driving its magnetosphere, the exact nature of which is not fully understood. Triton, Neptune's largest moon, is also of significant interest due to its geysers that expel nitrogen gas, indicating geothermal activity beneath its icy surface. These eruptions contribute to Neptune's tenuous ring system, as material from Triton escapes into space around the planet. Studying Triton may provide insights into geological processes that could also influence Neptune, making it a vital target for future missions. The observational data obtained from the JWST marks a significant advancement in our ability to study Neptune from a distance. The telescope's advanced infrared capabilities allow scientists to penetrate the planet's thick atmosphere and capture detailed images of its weather, ring system, and moons. However, to truly unravel the mysteries of Neptune and its environment, a dedicated mission capable of long-term, in-depth exploration will be essential. Until such a mission is realized, many of Neptune's secrets will remain tantalizingly out of reach. The Coriolis effect influences the rotational speed of a planet, with the highest speed at the equator and the lowest at the poles. When air streams from a high-pressure system outward or toward a low-pressure area, the system begins to rotate due to the varying speeds of air moving toward the north and south. As these storms on Neptune move in that direction, the Coriolis effect weakens near the equator, causing many of these storms to gather there. However, in September 2018, the Hubble Space Telescope observed a mysterious storm in Neptune's northern hemisphere, measuring over 7,000 kilometers wide, large enough to fit the entire continental United States. This storm was initially moving south, but by January 2020, it had reversed course and was heading north again. Neptune remains a mystery to scientists, and this storm is linked to two additional unusual phenomena. It appeared to generate a smaller dark storm when it changed direction and began moving north again. This behavior aligns with simulations of Neptune's atmosphere, which suggests that a large storm can produce smaller vortices as it disperses toward the equator. Although this smaller storm wasn't directly observed due to the distance, it may have occurred during the main storm's shift. Interestingly, unlike most dark storms, this one lacks the bright white clouds typically seen around its edges. These clouds are composed of methane ice crystals, which reflect light and appear white in images. The winds carry methane gas up the sides of the dark storm's high-pressure system, where it cools and crystallizes into orographic clouds, similar to those formed on Earth when air rises along a mountain. Images from 2019 showed the white clouds around Neptune, but they vanished at the beginning of this year. The unusual behavior of this dark storm may or may not be related to this phenomenon. Observing Neptune is challenging due to its great distance, making it appear small in telescopes. Furthermore, the planet's rapidly changing atmosphere complicates efforts to understand its dynamics. Neptune is also home to Triton, a large moon with a smooth, icy surface, which was captured by Voyager 2 in 1989. Triton is one of the most fascinating moons in our solar system. Recently, the James Webb Space Telescope focused on Neptune, providing some of the best images of its moons and rings in over 30 years. Methane, ammonia, and water are among the few chemicals detected in Neptune's atmosphere, yet the complexity of its environment remains a subject of ongoing research.